All right, let's get started. Thank you all. Today's topic is going to be Controllers 101. We have, we'll say, attempted to do controls training in the past. Some of it's been good, some of it's been bad. We're going to walk through some things, but we also got some live demos today, which will be something new. Hopefully you all find that useful. Today helping me with today's presentation will be Vince Fagerstrom. Most of you know him. If you don't, he's our CT product sales, market sales engineer. I know those things are evolving. He works with James Crooker, who's also joining us. Vince and I today will be, to start with, covering, we did a series last year and the year before, Programming 101, 201. Some of you may be aware of that. If you're not, I'm going to walk through what's available, what it is. More importantly, because it's going to touch on a lot of the things that Vince is going to talk about. The big presentation today will be selecting a controller, which Vince is going to walk through. Many of you have had questions, even to myself, about am I selecting the right controller? What are the options, the values? What am I looking for, and how to do that? So Vince is going to walk us through that. And after that, we've got some pre-recorded demo walkthroughs of the 4040, 4081, 6050, and 6040 overtemp that we're going to walk through and kind of point to. And so it doesn't substitute for the real thing. I know that, but it will give everybody some exposure to these so you'll be more familiar with the parameters and how to access these controllers as you're supporting customers and selling the products. So with that, Vince, you ready?
Let's do it.
All right, sounds good. So let's get started with a review or a walkthrough really quick to get everyone kind of gauged and set on what is available. And if you need to learn more, I've actually posted the links to both of these programs or we'll say set of videos. Training you on all the aspects of set point, process variable, what they are, and it's a real deep dive. We don't have enough time for that today, but the links are actually in the chat. You're more than welcome to all those if you haven't seen them already. You're also welcome to share those with customers. James Lewis, who I don't think is on the call today, did a really good job with walking through and explaining to you in detail why this setting is important and how this affects a process, which ultimately is going to help when James explained it to us in detail, is going to help you understand one, what are you selecting when Vince goes through selecting a controller, and more importantly, where those settings are in the controller. Program 101, we covered deep dive into P&ID control, tuning, inputs, outputs, your basic overview. The links are again in the chat. They're on the unpublished YouTube site. They'll be posted on the SharePoint and available to everyone. They are available to everyone. So I encourage all of you to touch on that. And if you're not familiar with these concepts or ideas I'm going to touch on, definitely reference that for more of a deep dive. Now, set point, I would hope everyone on the call understands what set point is, but that's just the start of all the programming and how the programming affects the controller controls the process. And there's ways to tighten up the process, to improve the process. And there's a lot of steps along the way, one of which is, the process variable. And we explain how that correlates to the set point, how we work through that, and more importantly, how the P&ID loop in the controller, so you got your proportional band, so think of how far, how long, how fast. So, that's where your ramp up time gets calculated and recalculated actually with the auto reset and the timing to avoid overshoot. You think about dialing it into the degree. We can do that if the settings are correct and you know what to look for. And in that video, which is actually the links there at the bottom, we talk about how to look for that and how to walk a customer through. The other reason I focus on the video so much is you can share this with your customer. You can say, hey, look, maybe I'm not entirely understanding it. Maybe you don't have time. You can shoot this to them, let them kind of study it up. They're short 5-10 minute videos that walk through that stuff. From there, it comes to the more standard stuff, like what's your input type, how to set those input types, and we're going to walk through that in a little bit. But there's a couple things that get overlooked that you may not be familiar with or have enough exposure to. And that would be maybe along the lines of an analog signal. It's very, very important in all of these controllers to scale them and how to scale them. And what I mean by scaling is there's a correlation of one, the scaling, like to what decimal point, to how granular you want your control. But there's also the side of the scaling that allows you to limit operator control. It also allows you to correlate, is back to as the example there, say a 4 to 20 milliamp. Well, at 20 milliamps, we're running at the high temp. At 4 milliamps, we're running at the low temp. And that's driving your demand. And that's where we get into your controllers, your contactors, your SCRs, and how the controller interacts with those. And then then your output capability is how you set that. It seems like a lot, but when you walk through it, 1, 2, 3, it starts to become a lot easier to have the conversation with your customer. It's a lot easier to select the right controller and understand what parameters you are looking for. Some of these controllers are more advanced than is needed for your application. Sometimes you need to go with the high dollar controller, but sometimes you don't. And that's where we want to avoid the confusion, know what to look for. And those are the things Vince is going to walk through with us here shortly. You think of stuff like, process high alarm, you set your band alarm. There's even a thing, called sensor break, where say the sensor is not reporting a signal. You can set up a controller to where it continues to operate off the assumption that it's there, off the assumption it's not. There's a lot of really specific settings that are great to have and to control, but if you don't maybe understand how they correlate to a process, it becomes a little difficult to advise or walk a customer through them. So those videos are certainly there for you to walk through. Again, talk about scaling a lot. You'll see that here in the videos, because that's actually, when you go right into the configure mode, that's some of the first settings you're going to see and why that's important and what scale you should be looking for. So you'll have a lot of talk about that. There are other settings in there. I call them gotchas a lot of times. Think of, there's reverse acting versus direct acting. Well, what do those terms mean? Well, actually, reverse acting, you got to think of it as this is your heating cycle. You're heating up, as opposed to a direct acting, which would be more of a cooling cycle. Vince will touch on that and explain that a little further in a minute. The programming 202 or 201 takes a little further dive into those communications and those settings. I welcome all of you to go through those. It's even got, mapping, more about the scaling. There's even configuration software and walkthroughs of how to set up our controllers. It's already available for you. I don't need to bore you with the details today, but I want to make you aware that that is already available, and some of you may not realize that. We talk about analog signals, how to program those, how to, what you're looking for. But again, the scaling is crucial. So the question, everyone gets a call about my process isn't working. What is wrong, right? Well, you think of as examples below, it's a problem with my PC, try restarting it. My phone's screwed up years ago, you just take the battery out. Well, if your controller is not behaving as expected, it might have to do just simply with the scaling of how, and we walk through how to find that scaling, what it is. You may not have to interpret it and understand it right now, because we're not the troubleshooting folks, but you have to have an understanding of it and its capability to know what's going on, because quite frankly, as soon as a customer has a problem, we're the first call they make. It would be good to have a knowledge of that to at least get them comfortable. I mean, ultimately solve their problem, but knowing where to go for support and having an understanding of that only helps your credibility with your customer. And that's what we touch on in those videos, and we walk you through. Inputs, we talk about scaling, how to integrate with the PLC is certainly part of that. And then obviously selection, we're going to go through in a minute with Vince. But your controller specific, that's actually the first thing I generally ask when somebody calls in. What is the controller? And it's not, is it a 4040? It's a 4040 what? So now we understand how many inputs we have, how many outputs we have, and how we can now understand, why is it not behaving as the customer is anticipated. There's a deep dive into control theory about, SSO drive, relays, analog, how you split up the the signal curve, and how that power correlates to the performance of the heater. So I don't worry all with that. All the way to remote set point, which again, guess what? Needs to be scaled. That is in there as well. I know this was just a short touch on all these things. I would hope that all of you have either watched or referenced these. I'm not saying you have to learn them all today. It's good to know it's there. It's good to get a refresher and know what you're doing. Again, helping your credibility with your customer, selecting the proper controller, understanding the programming to a degree. I'm not saying all of us, any of us, have to be experts, but you have to understand, and that's why I touched on this, the language and what we're looking at. So when we do the videos here in a little bit, you'll know what those settings are and whether they're affecting the process and how they're affecting the process. That was my short interim of going through what is available and talk a little bit of the jargon lingo so you'll understand what we're talking about later when we get to the videos. But more importantly, we're going to move on to selecting a controller with Vince. And Vince, I'm going to hand it off to you.
All right, sounds good. Thank you, Derek. And thank you all for joining. I know, I really appreciate everyone on here taking time on a Friday afternoon. And so, my promise to you for taking this time out on Friday afternoon is that I'm not going to be reading a bunch of, specs to you to memorize. What I'm trying to do in this little window here is really go through my thought process of, when I get a call or I'm talking to a customer or, any of you asking, which controller should I go for? These are the steps that I'm making in my mind to try to narrow down the possible selection, of where we want to go. So first things first, you've probably seen this before if you've been in any of my other controller trainings, but this is the thermal loop. The biggest question right off the bat is, are we talking about a temperature controller or a power controller? And a bit to what Derek has said in the past on this meeting here, temperature controller, using a sensor input or a signal input to control, you guessed it, the actual temperature, versus a power controller that's actually sending the electricity to our heaters. So, pretty obvious one right off the bat, but talking about temperature controller or power controller. So from there, for this first part here, we are assuming we are looking for a temperature controller. From there, very next question that you want to ask yourself or the customer is, are we talking about a process controller or a limit controller? And so, you might think, well, they kind of do the same thing, right? Well, not necessarily. With the process controller, trying to take your process variable up to a certain set point and keep it around that, on or around that set point. With the limit control, you tend to have that temperature be at a critical, temperature, whether that's the temperature where your process is really going to start getting, messed up, or there's going to be some damage to the equipment. With the limit controller, as I have highlighted here, there is a latching limit relay. So what that is with our regular process controllers, like a 4040, nothing really shuts down per se when the set point is exceeded. The controller does turn off, but as soon as it gets below that set point again, it's going to turn the equipment back on. With the limit control, if you go above that high limit temperature, it's going to stay off until somebody manually, resets it that says, hey, process is okay. Nothing is damaged or, on fire or something to that effect. We can get the process rolling again. Also, I wanted to show on this screen, there actually is a method behind the controller part numbers. As you can see here, every number for the first 4 digits of those controllers stands for something, at least the newer ones. So you can take a look where there's the DIN size there. That's the very first digit, so you know what size controller you're working with right off the bat. That second digit is, pretty much never anything besides a 0. The third digit there, you can see it's even for our temperature controls, odd for our limit controls. So that might make sense, why a 4040 is temperature control, but a 4050 is a limit control. And then the higher the number, the more advanced it is with more features. So, the 4020 is pretty, or the 6020 is pretty simple, and the 4080 series is a lot more advanced. So I wanted to highlight, arguably the most important section of our catalog for picking a controller. a lot of the time I'll get a call from either customer or one of y'all, and the first thing I'll do is just flip to this page. And really, it can make you seem a lot, especially if you're on the phone, make you seem a lot smarter than you are. Just really just go down this sheet, which we'll touch on, slide after slide here, break it down into a little bit more detail. But I mean, as far as selecting a controller goes, everything pretty much that you need to know is right here on these pages. So I wanted to make you all aware that that exists. So the very first question sets that I go off in my mind when talking about this type of stuff. First one is just, okay, is there already a controller that exists that is doing the job well, and all they're trying to do is replace it with something? If that's the question, or if the question or answer to that is yes, it really does simplify things. You just want to take into account, the size, how it's mounted, number of control loops, and then all the features. We can kind of break it apart, if you want. Try to find the all of the features and everything from the competitors controller, and we can work on that on a case by case basis. So that's kind of the first thing. But assuming this is a a new type of application or opportunity, what I move on then from there is, are there any sort of size requirements? Does it need to be panel facing, where an operator can get to it, right from the front of a panel, or does it need to be in a DIN rail, kind of tucked away? And also just the number of control loops. Does this controller just need to handle controlling, one heater? So the reason why I like to do these questions first, in my mind, physical restraints are really easy to identify and understand without any sort of knowledge of controller theory or anything like that. I mean, if you can eliminate a bunch of options just from this simple stuff like this right off the bat, I mean, you might as well do that. And also too, back to those pages on H4, those are the first 4 rows of the guide. So just knock those out right off the bat. It's going to narrow you down a lot. So the second question set that I think of is all about inputs and outputs. So inputs for our temperature controllers, they are really simple. If your customer is working with any sort of thermocouple or standard RTD, I mean, you can pretty much have extreme confidence that the controller can handle it. I mean, look at all those letters. It's like the whole alphabet pretty much on the inputs for the thermocouple. So, if you hear them say thermocouple RTD, you should feel good right there. If it's an analog input to your controller, you want to be a little bit more careful. You probably will be fine with any of, I guess what I'll say, kind of like the standard 40 series or 20 series, with analog. As you can see on the page here, they have pretty much all of those analog signals covered. The 30-second DIN controller options like the 3204, it's a little bit more limited. So just, be careful. It's always great to double check this page here, but for the most part, I mean, we call it a universal input for a reason. And then for the outputs, I really just use the guide. You want to hear if they're planning to use this controller in conjunction with a contactor for relay output, or an SSR or an SCR for the SSR drive. So your customer should know, or if not, you can give some gentle guidance, on what type of output you'll need there. But inputs and outputs are a strong second place to start to really start to narrow down your options. So question set 3 is basically, all the extra. So whether it's features like a ramp or a soak, or recipes, that's going to change what you want to work with. I have our 80 series controller with the chef's hat here. If you hear the customer say that they need a recipe, you will automatically hop to the 80 series. It is our only controller option that can do something like that. Really what that means, I mean, you can take the word recipe quite literally. You want it to be this temperature for 20 minutes, and then this temperature for half an hour, and then this temperature for 3 hours. So, none of our, I guess, standard, 40 series controllers can do that, but our 80 series has a lot more brain power in there that you can program something way more specific like that. The second, part of this, as far as the extra stuff goes, would be alarm functionality. And so the biggest differentiator there, would be heater break alarms, And, as you can imagine, our 20 series is extremely limited on the alarms and features. 40 series has a bit more. 80 series has a bit more than that. And then finally, we have communication options. A lot of the times for simple applications, you're not going to need to worry about that. But if you do, start to run into some requirements with Modbus, RS-485, TCP, Ethernet, things of that nature, just take a look at that chart, that I keep going back to, and make sure that it's on there. It's really is, as simple as that. So after you go through these 3 question sets, your possible choices as far as controllers that you even can use should be very small. And, my rule of thumb is to choose the simplest one that hits all of the features needed. So, I mean, if you want to do that. So in my opinion, 2 20 series or even, 2 40 series controllers, let's say you wanted to control 2 loops, using 2 of those simple controllers will actually be less expensive and way less complicated than using a 4082. So, I would recommend, if that kind of scenario pops up, unless there's some crazy space restraint that they need just 1 quarter DIN controller, using 2 simpler controllers to achieve an effect of 1 more complicated one is usually the way to go, in my opinion. So that's everything for our temperature controllers, how I kind of go through and narrow it down. Hopping back to the thermal loop here would be, how I go about choosing a power controller, which can be a little bit more, I don't know, nebulous or theoretical, I guess. I don't know. We can get into it, but yeah, we can move forward. So very first question is pretty simple. Are we talking about a contactor or an SSR or an SCR? So, contactor, very simple, on-off control. Want to be longer cycle time so the mechanical components of it don't get worn out. Really simple. And I'll say, just, as far as the CT world goes, if you have an end user and they're, interested in tossing in a contactor or 2 into a quote just so they can just kind of get it and get it done, I think that's a good opportunity to sell these contactors. But if you're working with an OEM and they're needing, 50 or 100 of these a year, probably we're not the best place to get that from, as far as just they're pretty expensive compared to, they can probably get some like Home Depot or something like that even. So if they are not using a contactor, they're almost certainly using an SCR. And that's when you're going to get way more control. PID control is a lot more functional on these types of controllers. The cycle time is way faster. There's no, hard mechanical components that can get worn out. And so yeah, I mean, those are really 90% of the time you're going to run into either a contactor or an SCR. So that's the first question. And then, so the first kind of real question then, after you get to, either a contactor or an SCR, for the purposes of this presentation, we're going to kind of dive deeper into selecting an SCR. Question 1 from there is, how many phases and legs? So, this basically will just match up with whatever the actual heater is as far as the phases. It's either a single phase heating element or, a flange heater with just 1 heating element on there, or it's 3 phases. So that's, quite a standard thing for us. So you just want to make sure you know what's going on there. Second thing is, you want to know, if it's 3 phases, are they okay with just having 2 leg control, which is less expensive, and really does almost the exact same thing as 3 legs, or do they absolutely need 3 legs because they need phase angle firing for some sort of true soft start? And those concepts are explained a lot more in James Lewis's previous videos. So I'm not going to take time to dive into all that. But, really simple question: how many, what phase we're working in, and if it's 3 phase, how many legs? Question 2 is the firing method. This one is a little bit more complicated. So you're going to, once you've determined the amount of the phase and the legs, you want to make sure if your customer is okay with a 0 cross firing method, whether it's time proportional or dot fired. And again, using that same chart for the SSRs, you can go through and look at that chart and see exactly what's on there. So for just as an explanation, the 0 cross that covers the second to last row there of proportional. And, for simplicity's sake on this chart, proportional means time proportional. And if it's a dot fire, they'll just have it in the parentheses there. Something else I will note is that for the CTF, the second column there, we have on there that it is phase angle fired. That is only the case if you are using this in single phase. You can use multiple CTFs to get 3-phase 2-leg or 3-phase 3-leg operation. If you do it that way, it will actually only be able to do a 0 cross firing method. It just gets really complicated with the timing if you have 3 separate controllers trying to do phase angle, just as a little FYI there. Yeah, and then so phase angle, it generates a lot more electrical noise, but for certain applications, it's necessary. And most of the time, your customer, actually almost all the time really, if your customer needs phase angle, I mean, they're going to know that and they're going to tell you. So 0 cross is fine for the vast majority of applications, unless stated. Okay, question 3 is also really simple. Mounting, line voltage, and current. So the mounting, most of the time, well, I shouldn't say most, but a lot of the time, as far as just how a panel is constructed, these SCRs and SSRs are just mounted to the rear of the panel. There are also, for some smaller SCRs, DIN rail mounted. That's usually not a make or break to any customer unless we're replacing an existing piece of equipment, but something to keep in mind. And then the line voltage and current load are really simple. Really just want to make sure that whatever you choose there matches up with the heater demands that they're using to, that they're controlling. That's really all it is to it. And then question 4 is going to be the inputs. If you remember when I was talking about the temperature controllers, when we get to inputs, life is really easy. It's almost the opposite for the SCR controllers. There's a lot more variation, and you want to make sure that you choose the right input. And yeah. So what I did here, the little snippet on the right, I'm not going to read all that right now, but James Lewis actually sent out a CT newsletter maybe a year or two now, or probably 2 years ago, and I really, really liked this snippet that he included on there. So if you have the time, I would, read this once we send it out. But this is really kind of a long way, a good explanation of a way to say that there's a difference between SSR drive and analog inputs. SSR drive has the pickup and dropout voltages. So those numbers, if you're talking to a customer, those numbers on the on that don't need to match up exactly. You'll see on a lot of our literature, we use 5 to 32 VDC. And that's just kind of what we've set as a company standard on our literature. The customer's numbers might be a little bit different, but it'll still be okay. For the analog control, we talked about 0 to 20 milliamps, 4 to 20 milliamps, all that kind of stuff. You want to make sure that if a customer tells you, any sort of analog range, that it does match exactly. So again, with the SSR drive, numbers don't need to match exactly, but for proportional analog type of stuff, they do. And finally, same last question again, features, alarms, communication. Didn't want to go through all of our options. It's kind of a lot, but just as kind of a general sense of how I look at our controller lineup. We have our luxury models of the C series, the CFW, CTF, C4. I mean, those things have just so many features, communication options, alarms. I mean, there's even, internal thermocouples on the SCR itself that make sure that the SCR itself doesn't overheat. Then we have kind of our mid-grade, used a lot with OEMs, or would be our Max Packs and our Mini Max. They have way less communication options as a C series, but they do have a good amount of alarms and some other features that'll come in handy. Plus, they're just compact and can handle some really high amperages as well. And then finally, we have the economy series, which is our CS series and SSR series of SSRs. They're really simple. The CS series has some simple alarms, but nothing groundbreaking by any means. If you're working with higher volumes, really just need something simple just to turn on and off a heater. That's where you're going to want to look. And to break down even further, so our SSR series controllers, they're often referred in the field as hockey pucks, and they are very, very cost competitive. There's companies that sell these, by the thousands, so it can be kind of tough. Um, and if we don't have an SSR model that you're looking for that's stocked, the lead times can be pretty crazy, especially nowadays. These come out of Italy, so I've seen some lead times for non-stocked SSRs of this model, that are in the 100 plus business days. So if you're working with, an OEM where it's going to be some consistent ordering, uh, I would strongly recommend the CS series. We have a much better relationship, to be quite frank, with the vendor for those series. Um, it's also cost competitive. The lead times for non-stocked units are still, in the 20 to 30 business day type of range. And honestly, if it's an OEM and the opportunity is big enough, we can absolutely look into stocking more of these too for an OEM. So just a little pointer there when you're out in the field. So yeah, I mean that's how I do it. That's really the steps that I take to narrow down. I know the controller section of our catalog can be very daunting. So I wanted to take 15 minutes really just to not go over specs per se, but just really a thought process that's going to help out with making sure that we move to a appropriate recommendation for a customer.
All right, thanks, Vince. Yeah, as you mentioned too, we do have some training, more deeper dives into the model numbers and stuff like that are available. Some of those links. So, Vince, good job. Now we're going to transition to something Vince and I were going to try to do before. We're not enough opportunity for us to get in front of a product. If a lot of you are like me, if it's heat trace, I've got to install it to understand how it works. If it's in the case of controllers, a lot of this is fun to be death by PowerPoint, right? And we can show you screen after screen or explain what it is, but we thought it would be better to walk through it and show you where the screens are, maybe even how you access the controllers a lot better. Something else that was pointed out to me earlier today too, this might be, this next section will obviously be recorded. You can have, you can use with your customers, maybe a distributor want it, stuff like that, but it's just a nice, this is and please bear with us, this is our first attempt at something like this, so we'll have some more time and better videos later. But we're going to transition over to this, and Vince, I believe you're going to do the 40/40 to start here.
Yeah, but real quick, if you everyone on the call here, if you have it, it would be beneficial to open up on maybe a second monitor or half the screen the 40 series quick start.
Exactly. Yes. Sorry, we meant to attach those to the meeting, but unfortunately, it wasn't allowing us to attach. But yeah, if you have the quick starts handy, that would be fantastic. And unfortunately, we can't send one of these controller boxes to everyone, but we're going to at least show you and walk you through it. And I do believe, and Vince and I are working on a kind of a share program to get those out to you as well. So Vince, you all ready?
All right, yeah, I'll do my best here.
Okay, we got prompts. I put prompts into the video, so we'll go along the way. So we'll go through the first controller now.
All right, sounds good. Yeah, so Derek and I rented out a room to go through and play around with these controllers and take some footage here. So right here, I'm actually, just using the quick start guide and getting into configuration mode from select mode here. On configuration mode, the default unlock code is 20. I would always recommend not changing that, just so it matches the literature there. So the first thing that happens is I go into the sensor selection, which in this case would be a J-type thermocouple with the engineering units of degrees Fahrenheit. And then you have to hit the manual auto button to keep it. The next two steps would be the scale range upper and lower limits. And Derek, you actually want to hit pause real quick?
Yeah, sure.
Just because I'm a little already behind there. So yeah, so with the scale range upper and lower limits, I know it's a very confusing topic, but there's really kind of two things. So we recommend setting it to 1000 for the upper limit and 0 for the lower limit. If you are using an analog input to this controller, It should automatically or default to that. If you are using a thermocouple, it will usually default to the temperature range of that thermocouple type. So if you ever go in here, and you're curious why for this controller it's already was at 1,000 to start, and for another one maybe it's at what's the K type, like 2,100 something degrees Fahrenheit. And
100.
yeah, so that's why those numbers when you get a new controller they might be different. So what we're doing here is kind of two things. So for a linear analog input, um, it's really important to have this be a nice easy number like 1,000, because it's going to translate your analog signal to engineering units. So if you keep it from at 1,000 and 0, if your analog input is sending like 50%, then your engineering units it would convert that to like 500 Fahrenheit. If that makes sense? So it's going to take that that milliamp signal and turn it into an engineering units degrees Fahrenheit type of signal. So if you have it a nice even number, it's going to be way easier to program that from the customer side of things. If you're using a thermocouple and RTD input, then this has a little bit of a different function. Anything that involves spans later on, which we'll get into, will work off of this ratio. So it's a lot of it's percentage based. So it's a lot easier to know what 10% of 1,000 is versus 10% of like 1,532, something like that. So that's what's going on there. Okay, so this is the control type. Would just be, it's going to default as single, which basically means just heat, not heat cool. Yeah, I mean, for vast majority, it's going to be in a single function, you're heating. For this is the primary output. Derek briefly talked about reverse versus direct acting. I like to think of direct acting being more like an air conditioner in your home. After the set point is hit, direct acting means you're going to turn on whatever process you have running once that set point is hit. We're in the heating world, we're a little bit backwards where we want our heater to be on and heating up a process until that set point is hit. So that's why, all of our controllers come standard reverse acting, because, you want the heater to turn off once the set point is hit, not the opposite. And then this is just, your alarm one, whatever your alarm output is, you can have that set to be a process high or process low. So you can see here, P high, P low. DE is a deviation alarm. There's band alarms. We can get into that in a little bit more detail, but wanted to touch on, some of the options there and how to get to them. And again, hit that man auto button. When you are in configuration mode, you must hit that man auto button to save whatever setting you just changed. Alrighty, PR1.
It's the output types.
Oh yeah, this is all the okay. Yeah, and then so for this, for like display, there's a bunch of options further down the list. If you're going through your quick start guide, you can kind of see all of those. Once you really get to, past kind of like the main stuff, for lack of a better phrase, you're really going to leave a lot of them be. There's no reason for you to change the display strategy or display type, and other things like that. I don't know if you want to keep moving on with this.
Yeah. No, it's good to point out that there's some default stuff that you shouldn't touch.
Yeah, so this is serial communications protocol. And a lot of the time, we're about to show you here. Whoa, we're moving. We are getting into some of the communication ports on the side of a panel. Don't want to go into that in too much detail right now, but that's how you change that type. This is the serial communication bit rate. Don't mess with that unless you have to, or your customer will probably be the one to determine that. Don't worry about that. This is your COM address. Again, your customer will deal with that because that's when they'll have to set up their whole system and communication system there. But at least now you know how to get there and what it is. And this is just changing between read and write or read only for those communication profiles. And yeah, so input output types. One.
A certain type of outputs are desired, triac, relay, SSR. You're just setting your outputs through different options here. RS-485, everyone knows what that is. Makes remote set point. I mentioned that earlier. And then some more stuff that comes up that's not in your quick guide is just simple product info, like, you know, date of manufacturer, that type of stuff. So moving on to setup mode, Vince.
Yep. So the unlock code for setup mode is 10 and not 20. Again, this is all in the quick start. Yep. So the offset. Actually, going back up real quick, Derek. Sorry.
Yeah.
Just back to that offset again, real quick. So offset's kind of a weird one. I would say, most of the time you don't need to mess with that, but Derek made a good point when we were working on this. Let's say sometimes just due to the natural constraints of the application, your thermocouple is further away from your process than you'd like. So with certainty really, that your thermocouple is reading about 10 degrees or whatever less than what is actually going on in the important part of the process. So if that's the case and there's really no way to get around that differential, you can use this offset feature to kind of what's the word I'm looking for here, to artificially change the variable that the sensor is giving. So you can kind of make it artificially adjust the temperatures to make sure that you're getting where you need to be, even if you can't measure the exact part of the process that you want to.
That's pretty accurate, yes. Well, and two, if there's a distance or a differential, say your process is 100, but you got to set it at 110. You don't want 110 on the controller. You're going to put 100, and you put the offset in there to deal with that.
Mm-hmm. Yep. Yeah. So these are the proportional bands. So this is the span I was talking about, going back to the scale range, upper and lower limit of 1,000 and 0. If you're working with a controller that's accepting a thermocouple or RTD input, something like that, this is how you mess with the proportional band of the PID control. So this is a percentage, and it's a percentage of that span. So in this particular case, what percent of 1,000 do we want the proportional band to really start kicking in? So I forget what I set this to exactly. I think it was like 10. So it would be 10% of 1,000, or so as soon as you're within 100 Fahrenheit of your set point, the P portion of the PID control will really be kicking in.
And that's important to remember as part of the scaling, because I know, at least in my own experience, I immediately go to the number, not the percentage. And it's a common misconception with a lot of our controllers.
That's why it's so important to have that nice even number like that.
Right.
Okay. Did we back up? Okay, there you go. The ARST automatic reset. That is the I of the PID control. Derek, do you want to? I like the way that you described the reset time there. If you want to speak to that briefly.
Well, yeah, well, the auto reset, and it actually quite commonly, more than not, when somebody's controller's not operating properly, I immediately go to the auto reset, because if the controller is trying to interpret the information that's coming in, this is the window. This is the window that the controller is interpreting from. So if it's a fast acting process, like a flow or something, where the variables change quickly. But your window now becomes the concern. So if the window's too tight, it doesn't have enough information to understand. It might overreact or underreact. If it's too long, it may take too long to react. A lot of times I find that the auto reset is usually set too small, because then it starts taking small bite-sized pieces of the process, right? We're getting to temperature, we're not getting to temperature. And if it's really short, you might be almost to temperature and it shoots at 100% and you don't want it to. So if you increase that time that it has to calculate its PID, it helps a lot of times. It'll slow its reaction, meaning when I say its reaction, the controller's reaction to activate the heater. So if we're talking 1 kW, 2 kW, not a big deal. If we're on scales of 100, 200 kW megawatt, right? This window needs to be a lot larger. And I know the default on these things, I don't know what the number is always very short. And if they run the auto tuning feature, which I think Vince will talk about in a second, it more times than not, it comes up very short. And you have to go back and change that number. So that's been my experience with it and my understanding. Like I said, James Lewis dives into it in some of that programming 101 too. But in troubleshooting or just helping a customer out, I've learned that that's usually the first thing I go to.
Yep, absolutely. And then this, the rate here is the derivative time, or the D in the PID. Sort of a similar thing, but you're actually looking kind of at the slope or into the future, if you will. If you take a, not to get all math on y'all, but if you take a derivative of a function, you're getting the slope, and that's basically the controller trying to calculate where you're going based off of that. So if you want to pause real quick, actually, Derek. So um, I know this is probably really, especially if you're newer to the company, this probably sounds like a lot of gibberish. If you are getting a new controller to your customer, I really, I wouldn't stress about what we just said until you get a little bit more comfortable with everything. Most of the time, I mean, especially for simpler processes, the controller right out of the box is going to work just fine, for getting to your temperature set point. If there's some stuff going on and they're running their process and they really just can't get the temperature for some reason, or they're getting wild overshoots, give either me or James, or ideally someone like Gus, a call, and we can kind of work through and see how we can tweak these a little bit. But I just want to make it kind of clear, don't get too hung up on all this right now. Out of the box, the controller is going to work very well for most of the applications, and then when the special stuff comes up, get us involved and we'll work through it together.
That's a good point, Vince. The intent's not to concern everyone or overwhelm you, but having exposure to it to not react. Oh no, I'm sure it's just a setting here and there is kind of the purpose of getting some exposure to this, because ideally we'd like to have these in all your hands. This is the closest we came.
Yeah, exactly. Okay, and then this is the manual reset. Now, okay, so here we go. SPUL. So can you pause it real quick?
I can.
Yep, thanks. So the next two things is going to be SPUL and SPLL. This one is kind of interesting to me. So this is if you are working with somebody that's, I guess, let's say like they're in charge of a process and they're a little bit concerned about the other operators. You can, and in this portion of the controller, narrow down where you can set the set point, or at least the range that you can set your process set point. So, if you want to make, let's say you're trying to control a process around 100 degrees Fahrenheit, and your operator is really concerned, maybe like there's some new people that are on site, you can, narrow down the absolute maximum and minimum set points, to be right around 100, so that even if somebody new is going to be using this controller, maybe unsupervised or something like that, they can't really mess it up too bad. So that's what these are used for, just to make sure that they can't set some outrageous value for their set point.
You mean people just come up and push the buttons? No way.
You mean people lie on the internet?
So yeah,
And then, that's just lower limit.
Okay.
Yep. LL, lower limit. All right, this one's kind of cool. OPUL, so that is the primary output power limit, is the textbook definition. basically the default of this is 100, as in 100%. If for some reason you don't want your heater to ever give 100% power, you can dial that back. Maybe, for example, some other company sold them a heater and they totally oversized it, and so they never want the heater to get 100% power. Maybe 75% would be more than enough. You can drop this down to 75 to make sure that you never burn anything up or something like that. Okay. Okay, so this is cycle time. This one, the default for, especially if it's an SSR, will be 1, as in 1 second. If you have a customer and they have a contactor and it's burning out really quick, I would take a look at the cycle time and try to get it as large as possible, just so that the contactor isn't continuously switching on and off and wearing out its mechanical properties. DISA, going through my list here. APT. Hey, Derek, which one's this?
I don't have the quick list in front of me.
No, I'm sorry. APT is the auto pre-tune, and then
that's auto tuning at the end. Yeah.
yeah. So a lot of these are set to be disabled out of the box. I wouldn't worry about these too much unless you're having discussions with the customer that are specific to this type of stuff. So just wouldn't worry about it too much. Leave that all disabled. It's better off that that's disabled and can't mess things up unless it's if your customer knows that they want it, then we can have that discussion. Yep. So SPR, ramp adjustment, local set point value. That's just the set point value of the controller right there in your hand. Local set point value.
All that to get to the set point, right?
Yeah.
No, that was good. So yeah, all that to get to the local set point and finish up. I know there was a lot of parameters, but again, just want to highlight and show all of these to everyone to virtually get the controller in your hands. So.
Yep. Oh, and real quick, so that you'll see that manual light lit up. All that means is that light is going to be actively lit while you are in setup mode. That's just telling you you're in setup mode. So as soon as you exit that light will be gone.
All right. We kind of dove in there a little further.
Yeah, we did.
Okay. I know we're getting kind of towards the end of the hour. We're gonna do the other controllers, and we'll do those if everyone's welcome to stick with us. I just want to be respectful of everyone's time. And we're gonna jump over there here in a second. But real quick, I do want to touch on a couple quick things for everyone in case some of you do have to jump or go on to something else. Again, all these things are being recorded and cataloged, and for reference later, they are going into the Academy, which we don't have it yet, but we're going to have a CT page with all the things that we spoke about and a lot of cool things that Vince and James are working on. Before everyone goes, because there was some confusion in the customer trainings, we did have the first one for sustainability 2 weeks ago. That'll be posted on the public site. Back to the CVPs, the oil and gas has been moved due to availability of some individuals to November 17th. The next one will be the chemical, the engineered chemicals, and that will still be November 3rd. Everyone's welcome to join, like get your customers involved. I just got a thing, marketing's putting it out on social media, and we will be presenting that to everyone. Also, along with this, we're also going to have Terminal Seals 101 coming up with James and Vince on November 6th as well. So just want to point that out to everyone before we get moving on. We are going to circle back and do these 3 controllers just for a demo, open up for comments, questions. But as respect to everyone's time, I know we're at the end of the hour. Does anybody have any questions at this point, or would like to have anything we'd like to see or talk, or have any things we'd like to show you before we go to these other controllers?
Hey, Vince, what is that 1 and 2 on the controller? Is that the input RTD? Or like, is it the number of processes?
Where on the controller?
You know how there's two lights, it says 1 and 2, right next to the, if you go back to one of the screens,
One of the screens of the video.
or the video, sorry.
Okay.
I think she's talking about the output 1 and 2 lights.
Yeah, is that, okay, yeah, so 1 and 2, is that the output? So you could have two
Oh,
processes?
yeah. Right. Yeah. Yep. Yeah. So just whenever either one of those outputs is active.
Okay. So it's the same setting for both then, right? Everything that, for both the outputs?
No, you can have different settings for different outputs.
Okay, okay.
This controller has two outputs.
And it might, I think all of them are printed with that on. A 4040 could potentially only, well, actually, don't quote me on that. Could potentially only have one output, but
That's what I thought, only one, but.
But
No,
most
so I
times
mean-
you only need one. That's true.
yeah, yeah. But I mean, output one might be, sending a signal to an SCR, and output two might just be some sort of alarm. So they won't always be flashing at the same time. So.
Yeah, the 4040 has up to 3 outputs.
Okay.
And Vince, I used my chart you just mentioned.
Aha.
Okay, any more questions? Again, I apologize for running a little bit over. We weren't sure how this was going to go, but we're going to go through the other ones here real quick. If you guys have a little bit more time, maybe shorten it up a little bit. So
Yeah.
I'll kick it off and run through this one. This one's actually I really enjoyed this controller, the 4080. There's an 81 and 82, 1 or 2 loop. Obviously the menus are much easier to access. You think of like it's not the fighter jet technology on the right, but it's much the interface is much smoother. You still got the same scenarios, setup wizard, supervisory mode, configuration mode. We know what that is now. Also has data logging. You can see that nice little USB port right there to take the information off. Like everything, there's a nuance. To get into any of these modes, the code is 10. So it's not 20 and 10, and this one is always 10. Now, as Vince kind of touched on, it's depending on what the customer would like, these are of course more expensive. Yes, there are higher end design thing because it's got the data logging, the charting. This also does recipes. He mentioned recipes earlier, and I'll go into that mode in a second. But you can kind of see as I touch through this, and again, much shorter touch on this controller. The interface is easier. The settings are much quicker to get to. They're the same thing. It's just maybe a little straightforward, we'll say. But it also has the capability, talk about this one being a more advanced controller of we call it profiling and recipes. And what that is, so basically there's 255 segments, meaning there's 255 different points of, you can do ramp soak. You maybe have to be at an X temperature, 100 for 20 seconds and then move it up. These are really intricate processes that this controller is capable of running. Again, arguably that could be, the own customer's design, their own communications, but this controller has the ability if they don't have that software or that design available to them now. It's a good option for them. You can run more than one process. That's again the 81, the 82. You go to the setup wizard, and there's some other things in there such as communications. You can kind of see me. You can see I'm literally tabbing through the pages, super easy. Input settings, we know what those are. That's your thermocouples, your RTDs. If it's an analog setting, that's another point. You can obviously customize a little bit based on where you want your decimal point or how you want it done. You can have several alarms along the process. But again, it's still the same settings: process high, process low, duration, the length of the alarm, reset, locking. You can see me touching through that, which is really quick. This is, power up, auto configuration. So a lot of the same stuff that Vince just touched on in a much shorter version. I'll skip ahead just a little bit because back to configuration modes at 10. You can have up to three outputs I think you saw there. Here's where you're selecting the type of output back to analog. And again, you still have to scale it, right, and calibrate it. And then they've got communications, and this one's kind of nice and clean. So you got this communicates with a DCS. They can not only does it do charting itself, it can be designed to send that to customer interface. Again, the USB port. You think of even integrating with a building management system, all capable from this high-end controller. And there, I fit it into a nice short package. So there's an introduction. Would like to, if anyone has any more time, we do have both of the other controllers to talk about. Most notably, and Vince, I'll leave it up to you. This 6050, the overtemp. I know we touched the process controllers enough.
Yeah, let's do the 6050 really quick, and then we'll call it.
Okay. Again, all good stuff. We just didn't know what time this would fit in. So let me skip over to that. And we'll get the 6050 rolling. Again, we'll put this for reference later, so I will hand it off to Vince.
All right, yeah, sounds good. So yeah, basically what I was kind of trying to do with this video was go through the quick start again. Entering into select mode, going into configuration mode, basically just following the instructions of the quick start. So this is me entering configuration mode. Again, the unlock code for configuration mode is 20. And as a reminder, on the 40 series, when you were in configuration mode only, you had to hit that manual reset button. For the 6050, it's the same thing, but it's that reset button. Just as a reminder there. So, the configuration mode will be pretty similar to the 40 series. Similar, input type, J-type thermocouple, Fahrenheit. This
Always hit the reset button. Yeah.
always hit that reset button. Yeah, so this is what I was talking about before, where with it's gonna set to that range to like a sensor type upper limit. We like to keep it simple and bring that back to 1,000. And it's kind of interesting with the 50 series. You should always do the configuration mode first when you're setting up a controller for the first time. But just as a heads up, when you change this to 1,000, it will actually set your upper limit later in the process to 1,000. So if you're wondering why that's happening, that's why. So this is going to be, and if you hold in the button, it starts to kind of skip through numbers and goes a lot faster, as you can see, versus just clicking it one at a time. We should have competitions on who can get the closest to 1,000 without letting go.
Hit that reset button again, or it won't. You'll move forward and it won't log. It'll go back to that 2100 number from the J thermocouple.
Yeah, you see that a lot in the field. It's easy to forget. This is painful. All right.
Yeah, reset.
Okay, next one is going to be, there you go. So offset again. We talked about that
We're really going to
before.
need the offset too much on overtemps because, quite frankly, they'll be attached to the heating element.
Yep. Yeah, so this, working with a high limit or a low limit. These are over temperature controllers. We work with heaters. We're going to use high limit here. So that just means when it has been exceeded, then it's going to shut everything off. Okay. Yep. See, so this will match whatever you just set your scale range upper and lower limits to. So it's going to be 1,000 here, and that's just the current set point to scale range maximum.
Type of alarm.
Yep. So, okay, actually, want to pause real quick here. So, you might want your alarm to actually be a lower value than your actual set point for these high limit controllers. If you have somebody that's on site looking at the application, that might give them time to fix something before the actual high limit has been reached, if that makes sense. So for example, um, I've been getting into smoking meats, and so I have a thermocouple set up, that I stick into, whether I'm making a chicken or pork or whatever. And so my end temperature on the chicken, I like to get to 165 Fahrenheit, but I set the alarm to something like 155 or even 160, just to give myself enough time to. I'll hear that alarm going off. I'm probably inside watching football. So I'll hear that. So it just gives me time to, get up, grab another beer, go outside, and make sure that I'm right there to, take the chicken off as soon as it gets to that temperature instead of reacting as soon as it happens, if that makes sense. So, maybe you want your alarm to go off before the actual, high limit scenario happens. Okay, so looks like from here, going to setup mode, same thing as the 40 series, unlock code is 10. All right, so here is the actual set point of the controller itself. And so like I said, it's gonna automatically match what we put for that scale range upper limit, which was 1,000. And so for the purposes of this, training, we wanted to drop down this set point just so that we could manufacture a exceed condition.
And Vince, also to point out that the reason that's 1,000 is you set your limit in the configuration mode. It defaulted to 1,000.
Yes. And so since we had the the control set to a high limit, it's going to take the upper limit that we did, which is 1,000. So if you had it on a low limit type of alarm, it would default to the 0 that we set.
Yeah, so now you're going to run it down, and we'll give a quick demonstration here. We're going to do a setting and show you actually going into alarm mode and how that happens.
Yep. And so, a lot of the time that the temperature that you'd set for this would be way higher than what we're doing right now. We just want to make sure that a heating element doesn't melt or some sort of oil or whatever isn't getting burnt. But for the purposes of this, we wanted to get that set point very low just so we could hit it and show you what happens. Okay, so I dropped the set point down to below the actual process variable that was being read. So process variable is 82 Fahrenheit, set point is 80. So boom, the exceed condition happens, okay? And so this shuts everything down. The exceed condition will go away as soon as the process variable is below your set point, which you'll see here in 1 second. So we're going to raise that. The exceed condition goes away. Boom. But if you'll notice, the out light is still lit up. So when I talked about the latching alarm earlier, this is what I was talking about, where once that condition is hit, the exceed light will go out, but everything is still shut down inside the panel. This controller is connected to a contactor that's kind of downstream of all the other SCRs. So when that contactor is shut off, everything is shut off in the process. So that's what makes an overtemp different from a process controller, because it will not turn back on until a human goes in there and actually presses that reset button and resets the controller and says, okay, everything's good to go. We can start running again.
All right.
Okay. Yeah.
So, yeah. We ran a little long there. I do apologize for that, but Vince, great job. I know that's a lot. Again, we're hopefully going to put some more integral and better production videos together at some point, but at least it gave us the opportunity to at least virtually have these in front of you and get somewhat of a comfortability with them. So that was the purpose of that. Other than that, Vince, thanks. Thanks everyone for joining us. We'll stick around for some questions.